Hello and welcome to the channel. So today in this video we will study what does the term polynomial means. We will also be looking at what are polynomial identities. Okay, so let's start. Okay, so over here they are saying we have come across algebraic expressions such as 3x squared minus 5x plus 2 and 3x minus 5. So expressions like these are called polynomials, which is a word derived from Greek and literally means many terms. So now we know that the term polynomial is derived from Greek and it literally means many terms. Okay, moving on, they're saying a polynomial in the variable x. More examples of polynomial are 8x cubed minus x squared plus 3x plus 4 and 5x4 minus 1 over 2x plus 1. N is a non-negative integer. So now we know what does polynomial means and what are some examples of polynomial. Moving forward, they are asking are x squared minus 2x power 1 over 2 plus 6 and x squared plus 1 over 2 minus 2 polynomials. So do you think are they polynomials? I know your answer will be no because you have already seen it, but we have to also see the reason. So yes, these are not polynomials, and the reason is because the former contains x 1 over 2. So you can see that the power of x is 1 over 2, and we have read over here that the power of n will be non-negative and will be a integer. So this is not an integer. Moving on, they are saying whereas the letter contains 1 over x. So we know that 1 over x means 1 over x with power 1, right? And when this x with power 1 will go upward, it will become x with power minus 1. So this is also a negative power, right? Minus 1 is a negative power. So this is also not an polynomial, because repeating again that we have already studied that the power of n in the polynomial will be a non-negative integer. So it will be non-negative and it will also be an integer. Okay, so over here 1 over 2 was not an integer because it was in fraction, and over here the power was minus 1, so it was negative. So this is the reason why both of them are not counted as polynomial. Okay, moving on, now they are saying in the term a x with power n, a is called the coefficient of x with power n. For example, the polynomial x cubed minus 2x squared plus 3 can be written as 1x cubed minus 2x squared plus 0x plus 3x 0, right? Why? Because we know that in maths we do not usually write 1, so x cubed means 1x cubed and minus 2x squared is as it is. Now we know that we have the term x cubed minus 2x squared and then we have plus 3. So obviously we all know that there should be a coefficient of x as well, right? So we will write it as 0x. Why? Since the coefficient of x over here is 0, so we don't usually write it. We skip this because this becomes complete 0, right? So we usually don't write it. And 3 has the x with power 0. So x with power 0 we know is equal to 1. This is something that you will study in the upcoming chapters in ADMAS. X with power 0 is always, anything with power 0 is always equals to 1. So when x with power 0 is equal to 1, so 3 multiplied by 1 is 3, right? So that's why we don't usually write x with power 0 after 3. Okay, so now we know that why this can be written in this form. Okay, now they are saying that the coefficient of x cubed is 1. So now we know that the coefficient of x cubed is 1, right? In the same way the coefficient of x squared is minus 2, right? The coefficient of x is 0 and the coefficient of x with power 0 is 3. Okay, in the same way if I ask you what is the coefficient of 5x squared, so you know that the coefficient of x squared is 5. What is the coefficient of x cubed over here? So if your answer is 1, then you are correct, because we don't usually write 1. So x cubed means 1x cubed. So the coefficient of x cubed is 1. In the same way, if I ask you what is the coefficient of x over here, so your answer should be 2. Okay, now moving on, they're saying the degree of a polynomial in x is the highest power of x. For example, the degree of x cube plus 2x is 3, 2x plus 8 is 1, and that of the constant 5, which means 5x with power 0 is 0. Now what does that line means is that, for example, if we take x cube plus 2x, let's just write it over here for your understanding. So for example, if I take x cube plus 2x, you can see that the power of x over here is cube, which is 3, and the power of x with 2 is 1, right? Now if I ask you which has the highest power, you will obviously say x because it has the power of 3, so the highest power is 3, right? In the same way, if we look at this polynomial, which is 2x plus 8, we know that the power of x with a constant is always 0, right? And the power of x with 2 is 1, right? So which is the highest power? Obviously your answer will be 1. So the highest power is 1. So these highest powers in a polynomial are called the degree. That's why they are saying that the degree of polynomial in x is the highest power of x. Okay, so now if someone asks you what is the degree in polynomial, you know that the degree of a polynomial in x is the highest power of x. Okay, moving on. Now they are saying consider the polynomial x squared plus 2x and 4x plus 3. Now x squared plus 2x is equal to 4x plus 3 holds only for x minus 1, x is equal to minus 1, and x is equal to 3. Thus x squared plus 2x is equal to 4x plus 3 is an equation whose solutions are minus 1 and 3. So from this, what we should understood is that whenever you equate two polynomials together, this always forms an equation. So the two polynomials over here were x squared plus 2x and 4x plus 3, right? And when I have equated them together, it has formed an equation x squared plus 2x is equal to 4x plus 3. And when you will solve this equation, you will get two solutions that are x is equal to minus 1 and x is equal to 3. Alright? Okay, moving on. Now they are saying consider the polynomials x squared minus 4 and x minus 2 multiplied by x plus 2. They are identical. That is, they are the same though expressed differently. So they are the same though expressed differently. Now what does that mean? Let me explain it to you. So that means, for example, let me first show you what x minus 2 multiplied by x plus 2 is. So if we multiply x minus 2 with x plus 2, we will get x squared, right, plus x multiplied by plus 2 is plus 2x, and plus 2 multiplied by minus 2x is minus 2x, and minus 2 plus 2 is minus 4. So we know that positive 2x and minus 2x will cancel, and the only thing that we are left with is x squared minus 4. Now you see that after multiplying, the polynomial that we get is x squared minus 4, which is the same as this. So now are you understanding why were they identical? This is why they were identical, because they both are the same though expressed differently. So they are written or they are expressed differently, but when you solve them, they both are the same. That is why they are identical, and that is what being identical means. Okay, moving on. So x squared minus 4 is equal to x minus 2 multiplied by x plus 2, right? We have already seen the proof, right? It's true for all values of x. The equality 1, so we have taken this as equality number 1, is called an identity and may be written as x squared minus 2 is equal to x minus 2 and multiplied by x plus 2. So they are saying that this is called an identity. Why? Because they both are identical and may be written as x squared minus 4 is equals to x minus 2 multiplied by x plus 2, right? Let me once again show it to you that x squared minus 4 is equal to x minus 2 x plus 2, right? And we have already seen that when we multiply x minus 2 with x plus 2, the polynomial that we get is x squared minus 4. So we know that x squared minus 4 is equal to this, which is equals to x square minus 4. So x square minus 4 is equals to x square minus 4. This has been proved, right? So this is why they are identical, because they both are same, but they are only written differently. So I hope now you guys have understood the basic terminologies, and in the upcoming videos we will go in depth of this chapter. So stay tuned.